to today's lesson. Today we are on lesson 1-4. Our objective for today is to identify an arithmetic series and work with sigma notation. Our language objective is to explain what makes a series arithmetic. So let's take a look at today's do now. Do now. For today, you guys are going to be looking for the common difference, D, and the 10th term for the following sequence. So I'm going to make you guys pause the video and try this on your own. Alright, so for the common difference, you should have got a decrease of 6. For the 10th term, we have it equal to -26. So let's look at today's thinking. What is a series? The sum of the terms of an arithmetic sequence is called an arithmetic series. Numeric example, if we have the following arithmetic sequence as given 3, 6, 9, 12, 15 all the way to 30. The arithmetic series would be 3 plus 6 plus 9 plus everything all the way to 30. We would add the first term and the last term, giving us a value of 33. We could add the second term with the second to last term, and it will still give us a value of 33. And I could keep going. I could add the third term with the second to last term, and it will give us a value of 33. And the pattern will continue. I would add the fourth term with the fourth to last term, giving us that value of 33. So since there are 10 terms in total, that means that we have 5 pairs whose sum is equal to 33. So how do I get this number? I take the total amount, divide by 2, giving us that 5, which tells us that the total sum must be equal to 33 times the amount of pairs, which in this case would be 165. So if I were to add the arithmetic sequence 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30, the sum will be equal to 165. You guys can try it. Add those numbers up. A numeric example, our algebraic example is very similar to the numeric. So let's say we have the following arithmetic sequence. A sub 1, A sub 2, all the way to A sub n. That means that the arithmetic series would be me adding all those numbers up. A sub 1, A sub 2, all the way up to A sub n. We would take the same approach as the numeric. We would add the first term with the last term, giving us some value. We would add the second term with the second to last term, giving us the same amount as the first piece. And we could continue that pattern as we did before, and the sum will always be the same. So in this case, we have a total of n terms. That means that the pairs are found by taking n, dividing it by 2, just like we did before. That's our number of pairs. And the sum will be equal to whatever the first and the last term summed up to. So let's look at our formula. The total number, S sub n, is expressed as the given formulas. We take the pairs and multiply by whatever the first and last term equaled, just like we did with that numeric example. This second formula is the same kind of concept, only that in this one we are using the common difference and the first term. Both of these are found in your formula booklet. You will not need to memorize. You would just need to know how to use it. So let us try the first example. Example number 1, finding the total sum of an arithmetic series. 1. Consider an arithmetic sequence 2, 6, 10, 14, and so forth. Find the common difference. D. Part B wants us to find the 10th term. And part C wants us to find the sum of the first 10 terms. So I want you guys to pause the video, do parts A and B on your own, and we will come back to do part C. Alright, so for part A, our common difference is positive 4. We're increasing by 4. For part B, the 10th term is equal to 38. So let us do part C. For part C, we're going to be using our formula to find the sum of the first 10 terms. So 2 ways you could do this. You could list out the 10 terms, or you could use what we already know for part B, that our 10th term is 38. So it's up to you. So there's my first 10 terms listed out. So we have our formula to be S sub n is equal to n divided by 2. That's the number of pairs times the first term plus the last term. So I'm going to use this formula and substitute n to be 10. So the sum of the first 10 terms is equal to 200. I can use the other formula as well, so I'll space this out. So we have S sub n, number of pairs, times twice the first term, plus n minus 1 times the common difference. So I'm going to quickly substitute, and we should end up at the same value of 200 here. And as you can see, still a value of 200. So it depends on what information we have been given that we may actually need that second formula. Let us look at our next piece. So in this part here, we're going to talk about sigma notation. We use sigma notation in a way to write the sum of numbers. The symbol right here, this means add up the terms. That's our sigma notation. Example, if we were given the series u sub 1 all the way to u sub 5, we can express this using sigma notation by starting with the first term, going all the way to the 5th term, and our formula or our rule will be u sub n. So let's try this. Example 2. So using sigma notation. Number 1, calculate the following sum. So we have the sum that is dealing with number 1 being our first term, number 3 being our third term, our last term, and our given rule. So let's do this the expanded way. So according to this, what they want us to do is take 2r plus 1, and we are starting off with r being 1. We're going to get some value there, and we're going to keep adding. Okay, so we start off with our rule, 2r plus 1. We're substituting r to be 1, our first term, r to be 2, our second term, and r to be 3, our last term. And at this point, let's just do our calculations and get the sum of these 3 terms. So the sum of these 3 terms is equal to 12. Or using sigma notation, we ended up at the sum of 12. Let's look at the second one here. For number 2, we have the same exact sigma notation. We have the same rule. We're starting off with the same R value, but this time we're going all the way up to 200. So for number 1, we did it the longer way. We showed how we're adding to get to our sum. For number 2, I do not want to add these values. There has to be a shortcut, right? So I'm going to show you the shortcut to this. So what we are going to do is we're going to apply what we learned of the arithmetic series. So I'm just going to quickly write the formula to arithmetic series. So what we are going to do is we're going to start off by finding the sum of the first and the last term. There's my setup, the first term and the last term. So quickly, let's just do it. So the first and the last term equal a total of 404. Now what we want to do is figure out what the number of pairs is. So we're going from the first term, 1, all the way to 200. How many pairs do we have? We have a total of 100 pairs, which means that we're going to take this sum of the first and the last and multiply that by our 100 pairs, giving us our sum 40,400. Let's do one more, again similar but slightly different. So just like before, we're going to take into account that we are adding a series of numbers. So I'm going to use somehow this formula. In this case, again, our rule has not changed, but this time our starting value has. We're going from 4 all the way to 200. So let's find out what the first term in this case plus the last term would equal. And I get a total of 410. Now what I need to figure out is how many pairs do we have? So we're starting off with 4 and we're going all the way to 200. All right, so for this, first what we want to do is figure out how many terms in total we have. So we have 200 minus 4 would give me 196, but I do need to also add back the 4, which would mean that I have 197 total terms. If I have 197 total terms, that means that I have, divide that by 2, a total of 98.5 pairs. Once I have the number of pairs, now I can figure out the sum of these terms. So I'm going to take that 410 multiplied by the number of pairs, giving me a value of 40,385. So keep learning, keep growing, and I will see you in our next video.